in a previous tutorial we had a look at expanding trigonometric brackets using the compound angle formulae. We're going to extend it a little bit here, and we're going to have a look at double angles. So I've written down there the compound angle formulae that you need to be able to use. They're in the formula sheet at the front of your paper or in your formula booklet, depending on your exam board. I'm going to extend this to look at double angles. So by double angle, I mean an angle like this one, theta, that's been doubled. So to expand this, we can rewrite this as sine of theta plus theta, where the first thing in the bracket is our letter A, the second thing is our letter B. So subbing those in, so theta plus theta is 2 theta, we get sine theta cos theta plus sine theta cos theta, which is 2 sine theta cos theta. And that's really worth remembering, because you could be expected to spot this here and be able to say, right, I know that's equal to sine of 2 theta. Doing something similar for cos of 2 theta, rewriting it as the sum of theta plus theta, and expanding, we get cos theta minus sine theta equals cos squared theta minus sine squared theta. Now there are alternative ways of writing this. If we rewrite cos squared theta as 1 minus sine squared theta, we end up with 1 minus 2 sine squared theta, which is equivalent. Instead, if we decided there to write sine squared theta as 1 minus cos squared theta, an alternative representation of this is cos squared theta minus 1, and again you'd be expected to spot these and recognise that it's equal to cos 2 theta, so you really do need to learn those. So let's apply these now to an exam question. So looking at this exam question here, which is from an old syllabus MEI paper, it's asking us to solve 2 sine 2 theta plus cos of 2 theta equals 1. So expanding this, that's 2 lots of 2 sine theta cos theta. So I got that because 2 times and sine of 2 theta we derived before is equal to 2 sine theta cos theta. Okay, so looking next to the cos of 2 theta, we've got to decide now which one of these is best to use. Is it the top, middle or bottom? Well, in this one I think the fewer extra trig terms that we introduce the better, so I think either one of these two would be a good way of going about it. So I'm just going to decide to use the middle one there, 1 minus sine squared theta. So plus 1 minus 2 sine squared theta equals 1. And if we take 1 from both sides now, we end up with 4 sine theta cos theta. And if I take 1 from both sides, it makes them disappear to give a 0 there, minus 2 sine squared theta equals 0. And notice now that I can factorise this. They've both got a factor of sine theta in common. Actually, 2 sine theta is the biggest common factor. So let's take 2 sine theta out as a factor. Okay, so we get 2 cos theta minus sine theta equals 0. And this is going somewhere now, because now it's nice and factorised. So I've got 2 brackets times together to equal 0. That means one of those things must be equal to 0. Either the first thing must be equal to 0, or the second thing must be equal to 0. So I've got 2 equations to solve now, so I can split my page down the middle and follow these 2 roots. So 2 sine theta equals 0. Well, that means if I divide by 2, that sine theta must equal 0. So theta must be the inverse sine of 0, which if you type in your calculator, you'll find is 0. So let's try and find all the alternative solutions now. So a picture of the graph, and we want all solutions according to the question between 0 and 360. So I can see that nought's a solution there. So following this along, there's another one there, and potentially another one there. But if you look closely at the type of inequality next to 360, it's not a less than or equal to, it's a less than, so 360 isn't a solution in this case. So just naught and 180. Having a look at the other one, I've got 2 cos theta minus sine theta equals 0. Okay, so if I take the sine theta over to the other side, I get 2 cos theta equals sine theta. And now this is the clever part, dividing both sides by cos theta gives me 2 is equal to sine theta over cos theta, which is equal to tan theta. So tan theta equals 2. Solving that, I get that theta equals the inverse tan of 2, which, popping that in the calculator, making sure it's in degrees mode, inverse tan of 2 is equal to 63.435. And looking at all solutions between 0 up to but not including 360, so there's my sketch of the tan graph. So that's 90, 180, asymptote at 270, 360. Okay, so roughly speaking 63.435 is about there. Following the line along, I can see there's another solution there, so I'll get that by starting at 180 and adding 63.435, so 180 plus that is 243.43, 243.43. Then rounding to 3 significant figures, finally I see that theta equals 63.4, it equals 243 to 3 significant figures, and not forgetting the ones that we've already done here, it equals 0 and it equals 180 also. So there's all 4 of the solutions. If you find these videos helpful, subscribe to our YouTube channel, and for more resources like this, go to alevelmathsrevision.com.